Hello class, this video is over lessons 19 and 20, factors and prime numbers, and greatest common factor. Please take a moment to copy the title into your notes. If you need to, pause the video. A factor of a number is a whole number that can be divided into another number without a remainder. Now we've already learned that factors multiplied together create a product. So if we consider the example 4 times 6 equals 24, 4 is a factor of 24 because you can divide 24 by 4 and the answer comes out without a remainder. Likewise, 6 is a factor of 24 because 24 divided by 6 comes out without a remainder. 24 also has other factors. We also know that 3 times 8 equals 24. So therefore, 3 is a factor of 24, since if we divide it comes out without a remainder. And 8 is a factor of 24, since if we divide it comes out without a remainder. If we continue like this until we find every possibility, we'll find all the factors of 24. The problem with this, though, is it'd be easy to miss something. So today I'm going to show you a method for how to find the factors of a number that should hopefully help you find every factor without missing any. And we're moving on in 3, 2, 1. So let's start by finding all the factors of 24. What we're going to do is create a little chart. So I'm going to start with 24 at the top and draw a line underneath it so that way there's a bit that hangs out on either side. Now, if you noticed in the two examples that we've already done, factors come in pairs. So I'm going to start with the easiest pair of factors for 24, which is 1 times 24. 1 and the number itself will always be a factor of your number. And so I like to call these the duh factors. What are factors of 24? Well, 1 and 24. Duh! So we start with our duh factors. From there, all we have to do is count. So I'm going to move on from 1. So 2. Does 2 go into 24 without having a remainder? Well, yes, it does. So I'm going to put 2 down. And 2 will pair up with, well, 2 times what is 24? 2 times 12. Keep counting. 1, 2, 3. Does 3 go into 24? Well, yeah, we had that from our example before. And that was 3 times 8. Keep counting. 1, 2, 3, 4. Also, we had that from our example before. 4 times 6. Keep counting. 1, 2, 3, 4, 5. Does 5 go into 24? No, it doesn't. At least not without a remainder. So I'm going to skip 5. Keep counting. 1, 2, 3, 4, 5. We're skipping. 6. But notice 6 is already over here on the other side. Once I count up from one side to the other, I know I'm done. So I have found all of the whole number of factors of 24. Moving on in 3, 2, 1. For our next example, let's find the factors of 36. Of course, we're going to start with our duh factors. So 36 has factors 1 and 36. Duh! And let's count. So 1, 2. Well, obviously 2 goes into 36 because it's even. Now, if you needed to at this point, if you don't know 2 times what is 36, do a little bit of scratch work off to the side. So I do know how many times 2 goes into 36, though. It goes in 18 times. Keep moving. 1, 2, 3. 3 obviously goes into 36. We know that 3 goes into 3. We know that 3 goes into 6. So obviously it's got to go into 36. Well, 3 goes into 3 once. 3 goes into 6 twice. It's 12. Keep counting. 1, 2, 3, 4. Hopefully we've all got it memorized that 4 does go into 36, and it's 4 times 9. 1, 2, 3, 4, 5. No, 5 does not go into 36 because it doesn't end in a 5 or a 0. So 1, 2, 3, 4, we're skipping 5. 6. Does 6 go into 36? Yes, it does. 6 times what, though? Well, 6 times itself. When you have a number that's going to be on both sides of the chart, instead of writing it twice, write it once in the middle. And since it's on both sides, once we hit this point, we know we're done. The benefit to writing it in the middle once is, well, first of all, you've only got to write it once. And second of all, if you're ever asked how many factors does 36 have, you can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9 whole number factors. And this way, I don't make the mistake of counting 6 twice. Moving on in 3, 2, 1. Let's try a slightly larger example now. 120. Duh. 1 and 120. 1, 2. Well, 2 goes in, it's even. I'll cut in half. That's 60. 1, 2, 3. Well, 3 goes into 12, so 3 will go into 120 as well. 3 goes into 12 4 times, so it must go into 120 40 times. 1, 2, 3, 4. Likewise, 4 goes into 12. So 4 must go into 120 30 times. 1, 2, 3, 4, 5. Well, my number ends in a 0. So yeah, 5 works this time. So 5 times what? Well, might need to do a little bit of scratch work off to the side. And if you do that, you should come up with 24. 1, 2, 3, 4, 5, 6. 6 goes into 12 twice. So 6 goes into 120 20 times. 1, 2, 3, 4, 5, 6, 7. Well, if you're not sure, do a little bit of scratch work off to the side. Seven goes into 1 0 times. 7 goes into 12 once. 1 times 7 is 7. Subtract, we get 5. Bring down the 0. 7 goes into 50 7 times. 7 times 7 is 49. subtract, we get 1. That 1 is a remainder. So 7 does not work. So keep counting. 1, 2, 3, 4, 5, 6, 7, 8. 8 does go into 120. One of the reasons why I know is if I take a look at some of these numbers over here, 8 goes into 40, 8 goes into 24. Well, if it goes into these factors, it must also go into 120. So if I do a little bit of scratch work, I'll find it's 8 times 15. I'm running out of room here, so I'm going to just shift over a little bit. Obviously, you won't do that on your papers. And we'll keep going. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. Using some tricks that I'll show you very soon here, I know that 9 does not go into 120. So keep moving. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I do know that 10 goes into 120 because it ends in a 0. So 10 times what? Well, 10 times 12. And now we keep going. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I know 11 does not work because hopefully we have memorized that 11 times 11 is 121. Well, that's too close for 11 to go into it. And we keep counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we've made it to the other side. So we have just found all of the factors of 120. Moving on in 3, 2, 1. A prime number is a number with exactly 2 factors. This may be a little bit different from what you've thought of as a prime number. Most of my 6th graders have thought that a prime number is a number that is only divisible by 1 and itself. Well, it's not actually the definition, but it is related. So, let's take a look. 2, if we write out the factors of 2, we start with the duh factors, 1 and 2. And we can see here we've instantly moved from one side to the other as we count. So we're done. With exactly 2 factors, 2 is a prime number. Three, start with the duh factors, and we count. 1, 2. 2 does not go into 3. And then 1, 2, 3. We've gone over to the other side. We're done. So 3 is also a prime number. I'm going to skip 4 and go on to 5. Put down my duh factors. 1, 2. 2 does not go into 5. 3 does not go into 5. 4 does not go into 5. And 1, 2, 3, 4, 5 brings me to the other side. So all 3 of these are prime numbers. Moving on in 3, 2, 1. A composite number is a number with more than 2 factors. So, for example, we skipped 4 earlier. Let's go back to it. We start with its duh factors, 1 and 4. And as we count, 1, 2. 2 goes into 4, and it's 2 times itself. So it goes in the middle, and we're done. Well, if we count these up, 1, 2, 3 factors. Well, that makes 4 a composite number. If we take a look back at our other examples of 24, 36, and 120, each of those obviously has more than 2 factors, so they would also be composite numbers. Now, consider, what do you think the number 1 is then? We'll talk about that in class. Moving on in 3, 2, 1. Our last concept of this lesson is greatest common factor. And I decided not to put a definition down for this because in the words themselves we find the definition. So, greatest common factor is going to be something I find between two numbers or more than two numbers. And to find it, I'm going to find their factors, figure out which ones they have in common, and then once I know that, I'm going to choose the greatest. For example, if we want to find the GCF of 24 and 36, we can use the work that we did earlier to speed this along. So my first step is to find their factors. So in a way we almost work backwards. So 24, we've already gotten this down. We're just going to copy it real quick here so that we've got a accurate representation of what the work should look like on the homework. And then 36, just copying it from earlier in our notes. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 on both sides. So ladies and gentlemen, at this point what I would like you to do is go through and box what factors they have in common. And so to do this, I would start with whatever number has the least factors. So here that'd be 24. And just go through and look whether or not they have them in common. So, do they both have 1s? Yes. Box them. Do they both have 2s? Yes. Box them. Do they both have 3s? Yes. Do they both have 4s? Yes. Do they both have 6s? Yes. Notice how I'm just working my way right around all the factors. So let's keep going. Do they both have 8s? No. Skip it. Do they both have 12s? Yes, they do. And finally, do they both have 24s? No. So boxed here, I have all of the common factors. All of the common factors. So to find the greatest common factor, we just take a look at what we have boxed, and we choose the greatest. We'll have everything boxed there. 12 is the greatest. And there it is. Moving on in 3, 2, 1. Let's do one more example. This time we're going to find the greatest common factor of 35, 42, and 48. So, first things first, well, first things last, technically, we're going to find all of their factors. So, 35, 1 and 35, 2 does not go into 35, 3 does not go into 35, 4 does not go into 35, 5 does though, and it's 5 times 7. 6 does not go into 35, and 7 is already on the other side. So there's all the factors of 35. Moving on to 42. 1 and 42. 2, well, it's even. So 2 goes into 4 twice, 2 goes into 2 once, 21. 3, well, 3 goes into 21, so I know it's got to go into 42 as well. And if we think about it, 3 goes into 21 7 times, and this is twice as much. So it must go in 14 times. 4, no. 5, no. And 6, I should have memorized. 6 times 7, which brings me to the other side. Finally, the factors of 48. 1 and 48. 2, I know because it's even. 2 goes into 4 twice, 2 goes into 8 4 times. 3, well again, I know that 3 goes into 24 8 times, so 3 must go into 48, which is twice as big, twice as many times. So twice 8 is 16. 4, yes. 4 goes into 4 once, 4 goes into 8 twice, so 4 times 12. 5, no. 6, we should have memorized. 6 times 8 is 48. 7's a no, and 8 brings me to the other side. So there's all of my factors. So now I'm going to find what they have in common. So even with 3 numbers, I'm still going to take a look just at the one that has the least number of factors. Now if you do one of the others, like if I looked at 42, it'd still work, it just takes more time. So I'm going to go through just these factors then. So do they all have 1s? Well, the answer to that's always going to be yes, so box it. Now do they all have 5s? Well, not only do they not all have 5s, none of the other ones have 5s. Okay, skip it. Do they all have 7s? Well, 42 has a 7, but 48 does not. So I can't box it. In order to be the GCF, it has to be something that they all have in common, not just that 2 of them have in common. And finally, 35. Do they all have a 35? Well, obviously not. And so I'm done finding the common factors. So now we choose the greatest. Well, the only common factor they have is 1. So obviously 1 is the greatest common factor. This video ends in 3, 2, 1.